Hi, David Lucier here from Summit Mountain Guides. I'm an ACMG mountain guide, and today we're here in the whitewater backcountry with Backcountry Skiing Canada, and we're going to do some snowpack tests. As you may have seen in the previous video, we've talked about site selection and digging a pit. Now we're going to talk about how to do your snowpack tests and selecting an area to do this snowpack test. One thing that's quite important is the dimension of your pits has to reflect the snowpack test that you're interested in doing. If you're only going to be doing a compression test, which takes about 30 by 30 centimeters width, you may not need as big of a pit wall as this one here. However, if you're going to be doing an extended column test, which we will do shortly here, you may want to have a slightly wider pit wall, like in this case. This width here is probably going to allow us to do both an extended column test, which is about 30 centimeters by 90 centimeters, as well as a compression test over on the far right side of the test here, of the pit wall. So let's start with a compression test. The first thing you have to figure out is where in the snow pit you're going to be doing your compression test. I've selected the right hand side here to do that because I'm going to do another test over on the left side. And the compression test is going to be on a 30 centimeter by 30 centimeter vertical snow column that needs to be isolated, and it's only going to be about 1.2 meters deep. It's a really good test to figure out what's happening in the upper snowpack and the weak layers in that area. So first you need to find something to measure with. You can have a saw with increments on it, or you can use a ruler or an avalanche probe, and you need to make sure you have enough space to create a 30 centimeter column. In this case it looks like I do. There we go. That's going to be where I'm going to start sawing on either side. But I also need to make sure I have enough room to excavate either side of the column. And there you have it. These are the regular dimensions. Next thing we're going to do is start digging. So here we go. We have our beautiful cutout compression test column. Again, the dimensions are 30 by 30, and I isolated all sides, so I cut all sides with my snow saw, nice and vertically, smoot walls on all sides, clearing the snow on the one side. This wide here allows you to cut the back a little bit more freely, and on the other side here, on the left side, I've got a little wedge of snow that I've excavated, that I've cut out with my saw and then excavated. And as I'm doing all this, as I'm cutting all sides in the back, I might already notice some weaknesses in the snow, and that's really important to keep that in mind. That might give you clues on where you would get shear results, perhaps, while you do the compression test. So the compression test is a series of 30 loading steps on the vertical snow column here, while you're hitting your shovel on top of the block with your hand, hinging at a few different levels and applying increasing force onto the shovel. The first 10 loading steps usually are done while you're hinging at the wrist, like this. And then, once you've done 10 taps like this, and by the way, you're just meant to be dropping your hand onto the shovel. You're not meant to apply force as you're doing this. Once you've done the first 10 loading steps, you're going to switch to hinging at the elbow, like this. And again, just dropping your hand onto the shovel over top of the column. After doing 10 taps, hinging at the elbow, you're gonna start hinging at the shoulder and drop your hand onto the shovel. So as you can see, each 10 steps in this sequence are increasingly more forceful by the nature of how we're doing it. And if we get any kind of results along the way here, we're going to observe that, make a note, but we're going to try and keep going with our test until we've done our 30 loading steps, so it's a little bit more homogeneous. Okay, so we just start by putting the shovel directly on top of the column, and I like to keep my elbow on the shovel shaft while I do at least the first 20 loading steps, and then you start tapping, and then we're gonna look into the column here, see if we get any results. So there's no results noted with the first 10 loading steps. I'm just gonna smoothen that out a little bit, put my shovel back on, and keep going with the next 10 loading step, hinging at the elbow this time. And now we're seeing some fracturing here. We call these more non-planar breaks, and that means that there are not really any significant weak layers here to shear very cleanly. It's just more broken. So that was 2 or 3 taps now, I think 3 taps into the elbow hinging. We're going to carry on. So there's no results so far, hinging at the elbow. I'm going to smooth it out one more time because I find the shovel kind of gets crooked, and it doesn't have that same impact on the column if you're tapping onto a diagonal column. So now we're going to be hinging at the shoulder, and again I'm just dropping my hand onto the column. Oh, right away we got a really nice shear here, very clean, and it was what I would call a sudden shear on this layer here. I'm going to make a note of this. Usually I like to make a little line in the snow pit, write down how many taps that was. It was 21 in this case. I know where that fits in the whole test. Good to keep that in mind for later, but I'm going to finish my test. Okay, so it appears that this was the only significant shear I got in this compression test. And it was down here, and it took 21 hits for it to shear, and it was a dynamic shear, which is interesting. There's generally 2 types of shears in all the different snowpack tests that we do. There's 2 main categories. They are either a resistant shear or a sudden shear. A resistant shear is a shear that would actually require quite a bit of force to slide off the block, but it would fail as a planar shear across the entire column or the block. A sudden shear will shear more dynamically across the block, and often will just slide right off or slide off a little bit depending on the incline. And the sudden shears are a lot more of a concern than the planar shear, because they usually mean that the weak layer is a little bit more dynamic, could propagate potentially great distances into the snowpack. Okay, so now let's look at the crystals and the weak layer where this shear occur. You can do that in a few different areas. I like to do it right next to where the shear was by just taking a little sample off of the pit wall beside it, flipping it upside down, and just scraping some of these crystals onto my crystal screen and having a look. And in this case, I can even pick some up underneath here. It appears to be a very significant surface-ore layer that was buried a while back, early in the season. And without even looking at it with my crystal lens, I can see the surface-ore crystals. They're really, really large, up to like 1.5 centimeters in length. And so if the avalanche bulletin was telling you something about a weak surface-ore layer buried in the snowpack, well then you've basically put the two and two together and figured out that this is what you're looking at in this particular spot. So with this kind of a shear result in a compression test, in 21 taps, the first tap basically hinging at the shoulder down about, in this case it was down about 50 centimeters. We're looking at a pretty significant avalanche here if this snow was to start sliding. And with the nature of the shear, the characteristic was sudden. It means that there's potential for wide propagation with this weak layer. And just by looking at the crystals, you can know why that this type of crystal is lingers for a long time and is really good bearing for propagation. So this maybe doesn't shear easily in our compression test. However, it's a dynamic shear, and so it falls into the lower probability, high consequence sort of result. And so you may not get this weak layer to go right away, but when it goes, it's probably going to go and propagate pretty far and be a large avalanche. So that sums it up. Now what we do with this in relation to where we're going to go skiing is very important, and that's something you need to learn as well. Thanks for watching. If you want to see more snowpack tests, go on backcountryskiingcanada.com. If you want to do some more learning, hands-on learning, Summit Mountain Guides offers avalanche courses, and we'd love to have you on. Thank you.